Hello, welcome to a new episode. After implementing defer in C++, I was thinking of implementing result types in C. In Rust, we have the result TE, which is basically a generic sum type. In C++, you can have a std variant since C++ 17. In C, you don't have basically generics. You can make generics using macros or void stars. So we can try the macro route. We'll have a result. And in C, basically macros are, the convention is to capitalize them. So TE, this will be a type def struct. Basically a tagged union with a tag. Let's say it's a char called isOK. And in an inner union, which has a T val and then ER. And we can instantiate this immediately, and we'll keep this type def open, so we can do something like result level int, and then my result, for example. And we can add something like unwrap functions here. And this will be a result value, and this will just get the inner val. So result val inner val. Instead of having people, for example, if we instantiate this my result R, instead of having to type, for example, R inner val, they can just go unwrap R and assign it to something. So let's rid of this, and the same thing for the unwrapper from Rust. This will be basically the same, just getting the and people can, for example, check if something is okay using the flag itself. So if R is okay, unwrap. If it's not, unwrap So we want to also add a convenience macro for the OK and OK something and something like from Rust. So we can also define OK value, and this just assigns the value into the inner val. So let's just use designated initializer. So it's okay. This will be 1. So as you know, in C and C++, bools can be implicitly constructed from integral types, and the syntax is for designated initializers. And here the inner val will equal the value, and basically the same thing for the this will be 0, and this will be and value. So now, for example, if we have a method or function, like a divide, so double x and double y, we want to check for the 0 here, for division by 0. So if y equals 0, we'll have to instantiate the type since we're using macros. So we can say my result equals and let's give it something, for example, like 1. We can maybe create our own error struct or enum. So let's see this in a bit. And the same thing for the other branch. And here this will be, for example, my result OK equals OK x over y. return okay. So here we can say my results are, let's divide example 9 over 0, and if r is okay, say print f okay. And includes studio. So this doesn't print anything since it's not okay. If we do like this, okay. So let's create our own error types. Let's use an enum, for example. Let's call it math errors. We basically have, let's say, success and division by 0, and this accepts a math error, and here we can pass a division by 0. We can also add something like a constr array, pointer array, so to be able to visualize these errors, for example. So this is implicitly 0, and here we can say constr error names, and this will be these two basically. Note this. Okay. So here, for example, if it's not okay, we can get the division, basically this string here. So we can unwrap where, and so this is R, and we can use this as the subscript for the error names. And we get division by 0, and else you can basically get the result of the division, so print f, and let's say unwrap R. So if we change this, let's say it's a 2, for example, and this prints correctly. Let's add a new line, for example. Okay, so let's separate this into a header file. So let's say results.h, and oops, what's this? Okay, no, we don't need this here. Okay. Okay. So that was basically it for this video. I hope you enjoyed, and hopefully I'll be making more videos soon. Thanks for watching. Bye.